Okay, so now that we have picked our particles, it's time for particle extraction. And I'll explain what that is in just a second, but to set it up, what we're going to do is go and get our micrograph file from earlier. So in this case, I've skipped a little bit. So I'm going to go with my CTF fine particles, but you can also use selected micrographs. And then we're going to give it a set of input coordinates, which is really what you're producing when you go through any set of picking step, like manual picking, auto picking, or template picking. So I'm going to come here, go to my auto pick stage, and select my Laplacian picked points. And we can re-extract particles later or use any of these fancy options, but for now we'll just keep it simple and move on to the next step. And this is where we start to make decisions about how we're going to process. So we have to give our particles a box size, and we have the option to bin our particles, and I'll explain what that means here. So let's open up our micrograph, and what we're giving the extraction option is our micrograph, which you should have seen before, and then represented in green by this green dot is a coordinate, an x and y coordinate. And what we're going to do is place a box around that coordinate represented by yellow, and we get to determine the size, and then we're extracting that into individual particles. So this is a stage in which a lot of people have issues when they're starting out, and I think it's worth talking about a couple vocabulary words. So when we talk about a micrograph, we're talking about the full image of all of these different particles. And then when we talk about coordinates, we're talking about the x and y position within that micrograph, represented by this green dot, of individual particles. And then when we talk about our box, we're talking about a particular area around that particle, or around that coordinate, which we're going to extract and treat as individual particles. Okay? And the act of particle extraction is placing a box around individual particles and extracting them as what's called a particle stack. It's a type of file, and in RELION it's abbreviated with a star file, as a star file. Okay? Now, to determine the size of box you want to use, it's dependent on a couple things. One is the particle diameter up here at the top, and the other is the pixel size given to you either by the person that collected the data, or it's a kind of intrinsic parameter based on the magnification and detector you use. So the common heuristic is that the box size you use is going to be the particle diameter times 2 divided by the pixel size. Now, we get into a new issue when we start to use very large boxes. So in this case, we're working with a particle that's about 200 angstroms across, and our pixel size is 0.885, which I usually just round to 1. So 200 times 2 is going to be 400. So if we're extracting with 400 pixels, so we're going to have an image that's 400 by 400 pixels, and each image will represent 160,000 data points. But if we can bin that, or reduce the number of pixels in that image by 4-fold, we reduce the amount of data exponentially to 10,000. And you can see that it's not without a catch, in that as we pixelate our image more and more, we start to lose resolution, as given by this image of Obama. And you can kind of see what we're talking about here when we talk about binning is we can group all of these pixels. So in this case we have a 4x4 and we can crop them so that they decrease in size from a 4x4 to a 2x2, but again we lose information that way. So going back, let's see, let's go back to RELION. We're going to, like we talked about, input our box size of 400 pixels, and we're going to rescale the particles, meaning we're going to bend them, and the size of the rescaled box is going to be 100 by 100 pixels. And this also results in a downsizing of the scale of the images as well. So now that we have all of that done, it's time to run our job. And I'm going to use 32 processes, and I also like to give an alias corresponding to how much I've bent the particles. So I'll say 400 down to 100, and then maybe the input that I used for picking. So it'd be auto pick 6. And now we'll run. So now that we've extracted our particles, we're ready to move on to 2D classification. That will be the next video.